Have you ever wondered how our sun, the glowing orb that gives us light, warmth, and life, came to be? The story of our sun begins in a nebula, a vast, sprawling cloud of gas and dust floating in the cosmos. This nebula wasn't just a lifeless void. It was teeming with potential, waiting for the spark of creation. Gravity, the cosmic sculptor, began to pull at the materials in the nebula. Slowly but surely, the gases and dust started to coalesce, forming a protostar. This protostar wasn't quite a star yet. It was a baby sun, learning to shine. As the protostar grew denser and hotter, a monumental event occurred. Nuclear fusion ignited. This process, where hydrogen atoms combined to form helium, unleashed a tremendous amount of energy, and so our sun began to shine. So our sun was born from a cosmic cloud, a simple yet profound beginning to a stellar journey. Now, having ignited its nuclear furnace, what happens to the sun next? Well, it enters a phase known as the main sequence, which is essentially the sun's middle age. This phase is a long, steady period lasting for about 10 billion years. During this time, the sun's core is a hub of nuclear reactions, where hydrogen atoms are fused together, creating helium. This process, known as nuclear fusion, is the heart of the sun's energy production. Picture this. Every second, the sun converts millions of tons of hydrogen into helium, releasing an enormous amount of energy in the form of light and heat. This energy is what we feel as sunlight, warming our planet and providing the energy that fuels life as we know it. Now, you might be wondering where our sun is in this process. Well, astronomers estimate that our sun is currently about halfway through this main sequence phase. So, it's been burning hydrogen for about 5 billion years, and has roughly the same amount of time left before it exhausts its hydrogen fuel. As the sun burns through its hydrogen, it maintains an intricate balance. The inward pull of gravity is perfectly balanced by the outward push of the energy being released by nuclear fusion. This keeps the sun stable, preventing it from either collapsing in on itself or exploding outwards. As it burns through its hydrogen fuel, our sun continues to shine, sustaining life on our planet. But what happens when the sun runs out of its hydrogen fuel? Well, the sun won't simply flicker out like a spent candle. No, it will undergo a dramatic transformation, entering a phase we refer to as the red giant phase. The sun, our familiar, life-giving star, will become an immense, bloated version of its former self. When the sun exhausts its hydrogen fuel, its core begins to contract under the force of gravity. This contraction generates an immense amount of heat, causing the core to become hotter and denser. And here's the thing, while the core is contracting, the outer layers of the sun are doing the exact opposite. They're expanding. As the core heats up, it provides enough energy to push the outer layers of the sun further out. This expansion causes the outer layers to cool down, and as they do, they change color. The sun, once a bright yellow star, will turn a deep, fiery red, hence the term red giant. This phase of the sun's life isn't a brief flicker in cosmic time. It's expected to last for a few million years. In its red giant phase, the sun will be a swollen, dying star, its light dimming as it nears the end of its life. And finally, how does the sun's journey end? It's a question that's fascinated astronomers for centuries. As the sun exhausts its nuclear fuel, it will undergo a dramatic transformation. Its outer layers, with light elements, will be expelled out into the cosmos, creating a spectacle known as a planetary nebula. Now, imagine a celestial fireworks show, with the sun as the star performer. As the sun's outer layers are flung into space, what remains is its hot, dense core, now a white dwarf. This is the sun's final stage, its swan song. Picture a tiny ember, all that's left of a once roaring bonfire. That's our sun. That's the white dwarf. A dense, hot core about the size of Earth, but with the mass of the sun. But the universe doesn't rush. Over the course of billions of years, this white dwarf will cool, its light slowly dimming until it becomes a black dwarf, invisible to the naked eye. Its fiery glow, once the heart of our solar system, gently fades into the cosmic night. Thus, our sun's journey ends, not with a bang, but with a slow, quiet fade into the cosmic night.